Hello, in this video I am going to explain series and parallel resonance. The experiment number is 6 here, which comes under VTU syllabus. So series and parallel resonance. The aim is to study the frequency resonance of series and parallel resonance circuits and hence to determine the inductance value of the given inductor, also to determine the bandwidth and Q factor of the series resonance circuit. Apparatus is audio frequency oscillator, AC millimeter, standard inductance coil, standard resistor and capacitors. Procedure. The circuit constructed is as shown in figure 1, so it will be shown in the next slide. Set the output voltage of the oscillator to some suitable value and keep it constant throughout the experiment. The frequency f is increased in suitable steps and the corresponding current is recorded. The resonance frequency for a maximum current must be determined with maximum accuracy. A graph of I versus f is plotted as shown in figure. The resonance frequency is noted from the graph. The inductance value of the coil is determined using given equation. The quality factor Q of the circuit is evaluated using the given equations. For parallel resonance, the circuit is also done in figure. The experiment is repeated as in series resonance. The readings are plotted as shown in figure. From the graph, the resonance frequency for minimum current is noted down. The unknown inductance value is determined using given equation. So here the formula used is for calculating inductance, L is equal to 1 by 4 pi square Fr square C, so many henries. So here Fr is the resonance frequency, C is the capacitance of the capacitor connected, and the quality factor Q is equal to Fr by delta F. Here Fr is resonance frequency and delta F is band width, that is equal to F2 minus F1, that will be calculated from the graph. And finally the quality factor theoretical value Q is equal to 1 by R into square root of L by C. So these were all the equations that we are used here. And in the next slide you can look at the series resonance circuit, and here L, C are connected in series, and when we plot a graph of current versus frequency, we are going to get a curve as shown in the picture. So the current will be maximum at resonance frequency Fr, and calculate Imax by root 2, and then if you draw a line from that point, so it will cut the curve at 2 points, that is F1 and F2. The difference F2 minus F1 is considered as bandwidth delta F. And in this circuit you can look at parallel resonance circuit. So here capacitor is connected parallel to L and R, and when we plot a graph of I, that is current I versus frequency, so current will be minimum at resonance frequency Fr. Next, we can look at the tabular column designed for recording both series and parallel readings. So here the frequency is started from 100 Hz and extended up to 2800 Hz, and the corresponding value of current in the circuit is recorded for both series and parallel circuits. And here is a tabular column. So it contains resistance, capacitor, resonance frequency, and then L is equal to 1 by 4 pi square Fr square C. Finally, the bandwidth delta F is equal to F2 minus F1, and quality factor Q is equal to 1 by R into square root of L by C. And graphical method of quality factor Q is equal to Fr by delta F. And for series, we are going to determine all the parameters, and parallel, we are going to calculate up to inductance value L. So finally, the result is recorded in the result column. And the demonstration video is available in the description. Thank you.